All right, this is the video for Tuesday, April 21. We're still dealing with radicals. Radical is anything that lives under one of those houses. That's the radical sign. And yesterday we talked about how you can have a square root or a cubic root or even a fourth root, and all of those are considered radicals. So anytime you see this house, it's a radical. Now, this is a radical sign. Whatever lives underneath the radical sign is called the radicand. Okay, you don't need to know that for many reasons in life, but you might see it on the SAT. It's the radicand. All right, so in order to do tonight's lesson correctly, we're going to need to review some things. And so on your worksheet, I have a full review here, okay? And the review talks about, for one thing, functions. Everybody gets all crazy about functions, right? Functions are not difficult at all. It just means that there is a definite relationship between x and y. Whatever happens to x in your formula is going to have a direct determination on what y is going to be. That being the case, you're going to grab x from anywhere. Your imagination, you just grab a number. You have to come up with your own x. You plug it into the equation and say, okay, so if x equals 2 or if x equals 10, what does y equal? Well, we're going to talk about radical functions, okay? In other words, functions that include the idea of the radical, all right? So let's think about this. If I have a radical function, it's got to have a variable in it, right? We're going to keep it with x and y. Literally any letters could be substituted in there, but because when we're talking about functions, it's got to come back to an x-axis and a y-axis eventually. I just like to go ahead and keep it with x and y. Let's think about what we know about square roots, okay? Square roots cannot... The radicand underneath the square root sign cannot be a negative number. In other words, the square root of negative 16 does not exist. Why? Because if I had 4 times 4, that's going to equal a positive 16. If I had negative 4 times negative 4, that will also equal a positive 16. In other words, there's no way to multiply a number by itself and end up with a negative number. So there's no such thing as a negative radicand. If that number in there is negative, there's no solution. Never. There's no real number in the whole wide world. There's no real number that would solve that problem. So we just say no solution. And yes, on occasion, you're going to see that. All right. So a function looks like... A function has a letter here. We usually start with f since function starts with f, but it can be any letter. It can be a of x, g of x, t of x, whatever, okay, equals something, and whatever is over here is going to have an x in it, okay? Don't be confused. People get thrown off. This means y, okay? This guy right here just means y, but the reason we don't just write y is because if I said y equals something x, you would think we were talking about like one number, okay? We're not talking about one number. We're talking about all the numbers, all the x's. Throw them in there, and so long as it's a real number, it's going to show up on a graph. It looks like this. This is confusing. People look at this f of x on the SAT and they go, I can't do this. What in the world is this all about? But the truth is, it's just y equals something x, okay? Now, if we're talking about radical functions, that means there's got to be a radical in our function. Now, in this particular case, I've written that the function of x equals, the function of x equals the square root of x. Now, that is the simplest radical function in the world, okay? Anything we do beyond that is just adding 2. However, you're going to need to do this. Now, I've done this one. I've done this in the worksheet, okay? In other words, I took function of x is the square root of x, and I did the whole thing right down to the graphing, right? So let's do, for our example, let's do it something a little more difficult. Let's say that the function of x is the square root of x times 2, okay? So 2 times the square root of x. Now the way I'm going to think about this is I'm going to say that y equals 2 times the square root of x. And what is x? Where do I get my x? Whatever in the world I want to put in there. Hint, hint, intimation, big hint. You get to choose the x. So if the x makes the problem hard to solve, it's your fault. If you want an easy problem to solve, then choose an easy number. In other words, choose an x that has an actual real number square root, okay? Would I choose 3 there? I could, but I'm going to end up with like a decimal. I don't want decimals. I want whole numbers, okay? And because I can't do every number, I'm going to do 4 numbers. Now, here's the deal. I know what my square numbers are. 0 times 0 is 0, 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. I know them all the way up, right? So I could say like, the square root of 144. I could say x is 144, and you know what that is, don't you? The square root of 144 is 12, because 12 times 12 is 144. So if I get to choose the numbers, this isn't cheating. You're always, for functions, you're always going to get to choose x. Choose an easy x. It's that simple. So here's what I'm going to do. I need to find several, because this is a function. It's not going to be just a straight line. It's going to do some funky things, okay? I can't just say, oh, well, give me 2 points then. 2 is not going to be enough. Give me 4 points, and I can kind of tell what this function is going to do, all right? Now, what I'm going to do is I'm going to make myself a graph. Now, in math parlance, we call this a master graph. I don't care if you call it a master graph. We're just going to make a graph, okay? It's going to look like this. It's going to have x on the top and y on the bottom. And because I want 4 values, I'm going to choose 4 x's, and I'm going to see what it gives me for y, okay? Where do my x's come from? My imagination. And I'm choosing easy ones. Like, there's no points against choosing easy ones. Now, if you're taking the SAT, guess who gets to choose the x's? You get to choose the x's, okay? So this is not something that's going to fail you when you get down the road. You get to choose it. So don't make a mystery of this. Just say, I want my x to be this. Here's a good hint. You know what a great one to start with is? 0. I'm going to say x equals 0. Now I have to go up here to my equation, and where it says x, I just plug in the 0 that I chose. So I'm going to say that y equals 2 times the square root of 0. What's the square root of 0? What times what equals 0? 0, okay? So y equals 2 times 0, which equals 0. In other words, y equals 0. If x equals 0, y equals 0. See what I did there? All right. So now, I have to do the same thing. Watch what I'm going to do. I'm going to choose numbers that are perfect squares. That's just me. I'm going to do it because I like it that way. I'm going to say x equals 1, because 1 times 1 is 1, right? So now I'm going to go back up here to my same math problem, and I'm going to say y equals 2 times the square root of 1. What's the square root of 1? 1. So in other words, y equals 2 times 1. Therefore, y equals 2. When x equals 1, y equals 2. All right. I'm going to go to my next perfect square, which is 4. Okay? You start to see the relationship here, aren't you? Okay? I'm going to put 4 in for x. Y equals 2 times the square root of 4. What's the square root of 4? 2. So y equals 2 times 2, or 4. Y equals 4. Okay? So when x equals 4, y equals 4, okay? All right, so I'm going to choose the next one. I'm going to say my next perfect square is 9. So for x, I'm going to put in 9. What's the square root of 9? It's 3. So 2 times the square root of 9 is 2 times 3. That's 6. So y equals 6. All right. So there we have it. I filled in my chart. Now I've got it, or my graph. I've got to do that first. Now I can graph it. Okay. Now I can take this and put it on my plane. Now, let's graph. Here's my x, here's my y, okay? And here are my ordered pairs, right? So x, y, when x is 0, y is 0, when x is 1, y is 2, when x is 4, y is 4, when x is 9, y is 6, okay? So now I'm going to plot those as points on the graph. 0, 0, right here. X is 1, y is 2, right here. X is 4, y is 4, right here. And x is 9, y is 6, right here. And I get this kind of look right there, okay? That's what a graphed radical is going to look like, as long as I'm not multiplying my radical times something negative, all right? So that's how you do it. That's how you graph a radical, and you just follow the same process through every time. It's as simple as it can be. Now, I'm going to give you a worksheet that has all the instructions and an example worked all the way through. You are going to work some of these problems on your own. Let me show you what that's going to look like. I'm going to erase all of this. Sorry for the long erasure. I forgot that I threw away my paper towel. Okay. So these are the problems you're going to do. And of course, do these on your own sheet of paper. And of course, show me all of your work, including your graphs, just like I do in the example. And let's do, I'm going to do some right out of the textbook. So here we go. Number 1 will be the f of x equals the square root of x plus 1. Number 2 will be, I'm going to switch it up here just so you get used to seeing it. The h of x. Guess what h of x means? It means y. Okay, the h of x will equal square root of x minus 2. Okay, all of that x minus 2 is your radicand. Now, when you choose an x, can you choose a number smaller than 2? No, you cannot, because your radicand cannot end up being negative. So you're going to have to choose something that is positive 2 or larger. That's a hint on that one. Okay, let's say let's do the f of x equals negative 3 times x. Number 4, the g of x equals the square root of x minus 4, and let's do one more, and we will say the m of x equals let's do one here that looks more interesting. How about negative 2 times x minus 1? All right, so those are your 5 problems. I'm going to read them aloud to you again. Again, Making it look like this, f of x or some other letter of x is code to let you know it's a function, right? And a function, you'll remember if you want to go back through your notes, a function has exactly one value of y for each x. In other words, you can't have a function and have lines that are on top of each other. Remember, if you can draw a straight line, a vertical line, and it goes through your graph more than once, it's not a function. So that's just a code that says it's a function, but all of these just mean y. That's it. T of x, f of x, h of x, it just means y. So I'm going to read these. Number one, the f of x equals the square root of x plus 1. The plus 1 is not part of the radicand. Number two, the h of x equals the square root of x minus 2. Minus 2 is part of your radicand. Number three, the f of x equals negative 3 times the square root of x. Interesting here. Pay attention. Let's think strategically in advance. What do you think is going to happen when you multiply the square root of x by a negative number? I think if you'll put some thought into it, you'll see your graph going to do something a little bit different than what it does if you're multiplying by a positive number or you're not multiplying by any number at all. G of x equals the square root of x minus 4, all right? And number 5, the m of x equals negative 2 times the square root of x minus 1, and x minus 1 is all part of the radicand. All right, there we go.